but we're starting to talk about low-level memory um, and C++. And so let's see here. I'm gonna go on my screen. So first thing I'm going to do is talk about how to compile a program real quick, because I think you may have missed all this, right, Justin? So GCC is the compiler. The file is main.cpp. .cpp files are C++ files. -o means output, and then hello means what you want the name of the binary to be. So it takes source code, transitions that to binary. If I press that, I now have hello in the directory. If I want to run that file, I can do /hello, and it runs and it prints out test, which is what this code is having to do. So that's basically how you do command line compiling with C++. Up at the top, if you remember in Python how we had import and you would import a library, we have similar things in C++, except that we call them pre-processing directives. That's like the actual name for them. And hashtag include is how you do it. And then you name the kind of the library you want to import. You can import it with that, or you can import it with these kind of, I don't know what you call that, plus or greater than signs, but whatever character it is. And there's differences on when you use some of that syntax, but that's kind of white noise. There's this other thing that we didn't talk about, which is namespace. And namespace is basically a way to deconflict names. And so in Python, you don't have this. And in a lot of other languages, you don't have this. But in C++, you do for a lot of specific reasons. So if I have two functions that are named the same, or two classes that are named the same, and I have two different code bases, and one's for like cars and one's for like engines, but they both have a class named car in them. Well, the code and the compiler doesn't know which one to use when you start to hook those code bases together. So we add this extra layer of naming called a namespace. And it might be like the engine namespace and then car, and the engine namespace and then engine. I mean, sorry, car namespace and then engine, and then the car namespace and then car, so that you know by that namespace that those functions are different or those classes are different. And I'll talk about that a little bit as we go through. This is an example of namespace, though, STD, which stands for standard. And it happens to be the standard namespace for all the functions and libraries that come with C++. Now, you can create your own namespaces for other things, and it's a good practice to do so, but that's why you're going to see that moniker. This right here is the same thing as the init function in Python. It's the standard entry point. So when it says int main, it's the standard entry point for C++. So when you run the code, the first function it's going to run is it's going to run main. What else did we cover? Before we go into this, let's do a little backtrack here and reopen this code. Instead of hashtag, by the way, it is // for comments in C++. And if you want to do multi-line comments, it is that. We have like a little colon, and then anything I type in the middle ends up being multi-lines. Just a little syntax information for you before we get started here. All right. Let's do this. Yeah. So before we get to any memory management, we're just going to talk basic like C++ syntax here because it's a little different. So in C++, you have to specify the types of everything, which you did in Python. It's required to specify the types. If you don't, you'll get errors. So we're specifying the type as a standard string. And this was with a pointer. I need to do one without a pointer just to start with the completion. Let me do this. Let me copy it up here. I don't want to get into pointers until I just talk about doing everything without low-level memory management. We could do this. So we're going to do that. We're going to do that, that. Okay. So right now what you're seeing is we declared a string type A, but we didn't define it yet. So in order to use it, we have to define it, which means we have to assign it a value. So we're going to assign it string, which is what we did in Python. Looks very similar there. And then this std cout and std endl stands for command line out and inline. You can think of this as like a line break, and you can think of this as like just printing the command line. And these little double carets just basically mean extend it out. And what's in between is what we're sending out, which is A. So if I save this, I do a compilation step here, and I print hello, I get test. So this is the same as the print function in Python. If you ask me why it's weird in C++, honestly, I don't know. Like sometimes you get really weird syntax like this. There are some other functions that will print to the command line that do not require you, that looks more like Python. But in C++, this is kind of what you have. If you don't add endl, it just won't print to the next line. So like if I were to go like this, I'm sorry, file, hello, it prints test twice, but it doesn't have a line break in between them. So it's kind of the situation you face with C++. Okay. Everything that I showed you right there, and you have to have a return, but the return right here is 0. The other thing to know is that you have to specify a return type in the function, and that is specified before the function. So, in Python, when you define a function, you did Jeff. In C++, you define a function, you have to do int. You have to basically specify the type you're getting back. That's also a requirement. Also, if you have arguments, you have to specify those types in there. You do std string B, but you have to specify those types. You can't just do A and B. There's no type guessing in C++.
Got it.
The other thing to know in C++ is that with that namespace, I know I was using std there. That's the namespace for IOStream, which is a standard C++ library that lets you do both string type and send out to the command line. The other thing to know here is that I could do a fancy thing, preprocessing directives that is including namespace std. I have to do that. No, maybe it's just include. No, I know it's included. First off, we have it right here. Okay, so let me go. There's no error. Just double test if there's no error here. Okay, there's no real error. That's just a squiggly line.
Did we lose Ron? I think so. Mav seems adventurous this morning.
It's awful.
Saw him up next.
I can't wait to give him to my parents.
Sorry about that.
All good.
Looks like it's still going. Okay, so I'm just going to reshare my screen. So ignore this squiggly. That's not a real error. That's just a VS Code styling situation. I'm trying to get it to where I can actually see you guys. I'm going to minimize myself here. All right. Okay, so you got a preprocessing directive. You can do including namespace std instead of std here.
That's super useful.
But that's bad practice. I have an error here.
No.
Something is wrong here. How do I do including this? Hold on. Including main. It's stuck on the floor. Using namespace. Why did I say including? That's where the error was.
So you said that's bad practice.
Yes. And
Is that
I'll
just
tell you-
because it's not denoting for
Correct.
the reader? Yeah.
it's better for the reader to know, and it's better to just not have. Yeah, it's way easier in general. Yeah. All right. So okay. So what you just saw here too. This is the other piece to know. We're about to talk about rollover memory, but what you're seeing here is basically declaring a variable on something called the stack. Assigning variable the value of size, and then printing the value of that variable to the command line. Okay, so that's essentially what's happening here. And it's important to know, it's important that I delineated that, but I'm going to tell you why. So I told Rachel about this last time, but there's actually I was trying to pull the picture to give you guys some sort of a reference here, so I'm going to do that now. There are two pieces in memory called the stack and the heap. That's the best way. I like this version a little bit better. Can you guys see that okay? Without hitting a YouTube
Yeah.
video.
Yep, I can see. It.
Actually, this version is great. Okay, so you got the stack and you got the heap, and they're kind of two separate pieces in the RAM of memory. So when an application actually loads, you have it loads up a certain amount of memory, like nominally like 2 gigabytes, for instance, in the stack and the heap. It can be variable, and that gets into other things that I'm not even really qualified to talk about. But like nominally, it's like 2 gigabytes you can think about. So a very small slither, like a few hundred megabits, will be the stack. So it's this tiny little kind of slither off on the side. And then the rest of it, this bigger chunk of memory, is called the heap. And Stack Overflow came from actually this, if you're curious where Stack Overflow came from. Also, there's a data structure called stack. So it's kind of a mix between the two. But stack itself is where all the code runs. So it's small, it's lightweight, and the code is executing in the stack through the CPU back to the stack. All the functions sit in the stack, they're loaded onto the stack, and they run. The local variables to functions that are not pointers or references fall on the stack, and they run. The heap is used for like kind of the bigger storage while the program's executing, not like database storage in an SSD or a hard drive, just like bigger storage for the application. And so what happens is, you in C++, you have the ability to determine where you are going to store variables and the scope of the variables. And based on determining that, you'll build references and pointers or values, and you'll store them on the stack or the heap. And you will determine where you do that and for what reason. One thing to note is that the stack runs a little bit faster. So if you're like super high efficiency, like code, you try to avoid as many pointers as possible. That's not always possible. But for your general application, like it doesn't matter as much. It just matters that you're being safe, because now that you have the ability to manipulate the memory, you also have the ability to mess up pieces of your application. And in some ways you could mess up pieces of your computer, though that's way harder. So that's kind of your stack heap 101. Let's go back to the code now and talk about kind of why some of this matters. All right, so stack heap. Okay, so strings. So what we did here was this was all on the stack. This entire set of variables was on the stack. And that's because I didn't define a pointer or a reference. Now let's scroll down a little bit and talk about the three types of memory, for lack of better words, within C++. You have pointers, you have references, and you have values. Most of the time, values are just on the heap. And values are a local variable stored in memory. It's data, it's not a memory address. Though the code knows where the memory address is, when you're accessing it, you're not storing the memory address. You're actually just storing the variable, and that memory address is just kind of known in the stack. I know it's a little confusing. I'll explain it a little bit more when we get into this. The reference, or let me explain a pointer next because that needs to be explained first. A pointer points to a memory address, not to a value. So the pointer points to literally the RAM memory address. That's like 0xf, blah, 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 this really garbage hexadecimal number, not the actual value. So when you're passing around a pointer, you're passing around basically a string that points to that memory address. When you dereference it, the memory basically in the stack leaves that, or takes that memory address, goes and finds it in the heap, finds the data, pulls the data in and manipulates it. And a reference is basically the same thing as a pointer, except you can't change the memory address it's pointing to. So with a pointer, you can be like, you can mess up in your program and be like, I have a pointer, and then you can say, I want that pointer to equal like some other thing. And then you go along your code and you try to dereference it and it fails. That's because it's no longer pointing to the memory address. It's now pointing to some random other value you assigned it, and it can't dereference that in memory. So before I get into how that looks in code, a pointer points to a memory address, a value points to a value, and a reference points to a memory address that cannot be reassigned to a different memory address. That's the cleanest way to think about it. So if we come up into code and we now ignore this, I'm going to pull up the pointer first, and we'll talk about the pointer. So I'm going to uncomment a pointer. Talk through this code here. So we have our type. This little star character is how you specify that a variable is a pointer. So I put the star character in front of the A. You can do it like this. You can do it like this. Or you can do it like this. This is standard practice. This is my bad practice because it's how I learn. We'll just pick somewhere in the middle. It really doesn't matter. As long as it's in between those, it defines it as A, and there's no character error. So the white space doesn't matter. So this is now a pointer that points to a memory address. It doesn't point to, it points by default to a memory address that is called the null memory address, which is basically the zero memory, the first memory block in the application. You don't have to define it, though. You're just declaring it. So I'm going to say this is going to have a memory address. If I define it, that means I assign it something. So what I'm doing is the next step is I'm saying A is going to equal a new string on the heap. Why is it on the heap? It's because the new keyword is in there. Anytime the new keyword is in there, you're building an object on the heap. A string is an object in C++. A char is a primitive in C++, but a string is actually an object. So you're now building an object on the heap in memory, and A is pointing to that object. It's pointing to the memory address of that object. Now, if I want to affect the value of that object, like I want to actually change the value, I have to put this star character to dereference the pointer, meaning take that memory address, go and find that location in memory, and then assign it the value of test. So it found the memory, it knows it's a type string, and it says, I will now assign it in memory the value of test. Then you come down here to see out and you print out. You have to dereference it first, saying like, take that memory address, go find the memory, or go find the value, pull the value in, and print it out. So I'm going to do here is I'm going to show you two things. I'm going to print out A without dereferencing and A with dereferencing. File this code. Okay, so two things happen. This print without dereferencing printed out the memory address because that variable in the stack is storing the memory address. It's not storing the value. The dereferencing says, okay, variable in the stack, I want you to go find that value at that memory address and print that out instead. And so it went and found the value and printed it out. Does that make sense with a pointer to start? And what questions do you have?
Makes sense to me.
Okay. And I'll just, before I comment this out, I'll just say,
So pretty much the pointer creates like a slot.
Yep.
And then the new fills that slot. And then you
Yes.
can assign it later.
Yeah.
Okay.
Correct. And let me print the value at the memory address.
So
Let's
maybe I
do
missed this in how you covered the stacks and the heaps, but
Yeah.
I guess what's the benefit of doing it this way versus just saying A is equal to test?
Great. Yeah, great point. So this comes into something called variable scoping, where if I just have A and I'm in a class, it's only locally scoped to that function that it's running in, and then it
Oh, okay.
gets wiped. If I want to store something persistently between classes and functions, I have to create it in the heap, and then I can like return it out of a class, and I have access to that piece of memory over in the heap
Got it.
the entire time.
So it's kind of
What's
like
weird
a
ab-
global variable for your software in a way.
Yeah, yeah. And Python, let me double check here. Is Python passed by? Copy of the reference data out there. Okay, not a copy of the object itself. Okay, so this is I have to get through some basics here and then get the functions, and that question will become way more clear to you,
Okay.
Justin. Python is essentially functionally passing by value, but it's not actually doing that internally. It's doing something fancier. Okay, let me show you a reference real quick as another example. I'm not an expert in this, by the way. Sometimes I still get confused, but I've done this like for a lot of years and I know the basics now. But okay. Let's talk about references. So we declare value a variable on the stack, same as before, except we don't have a pointer to it. This is just your local variable. Now we create another variable called a reference, and the reference is just like we did with this A. The reference is with an ampersand. And again, it doesn't really matter where you stick it in between this. I just am doing it here in the middle, just for the sake of simplicity. So A equals S. So I'm saying this reference now points to that memory address. I remember when I said a reference is a pointer that cannot be changed. So it points to the memory address, but because it cannot be changed, I don't have to dereference it. The code knows to dereference it automatically. So up here, I had to dereference it to change its value. Here, I don't have to dereference it to change its value. So I don't have to put the star because it can't be changed. Like I can't go into here if I said A equals test. What would happen is that this would change the local variable in the stack. It would change the value of the memory address, to what it thinks is a new memory address called test, which is not a memory address, which will result in an error in the code. This won't do that because there's no way to not affect the value in the heap. Does that make sense? I can maybe I can run an example
Yeah, that
with
makes
both
sense.
of those. To,
Yeah, let's do that.
let me see if I can pull this off. It's been forever since I've done this. Hopefully, I don't get an error doing this, or like a catastrophic error. Maybe this tough. Const cannot be assigned a value entity string. Okay, let me just do this. Oh, it's a const. It's not const. It's a. Let's try this. E equals C. CG. How do I do this? Let me do a different pointer. I know for a fact that will work. So I'm just going to make a different pointer up here. All right. That's going to be called B. And I'm going to give it a different value. A equals new std string. Let me close this out real quick. Okay, so that's a new like pointer basically, right? If I say A equals B, I'm just gonna assign it a value real quick, like test2. And now I print out A. And I have some error here. The point is that if you assign A to a different pointer, it's now just going to flip the memory address over. But I actually can't do that with a reference. So we'll worry about that next week and run that example. But there's a difference where you can change the address of a pointer and you can't change the address of a reference, but they're both in the heap.
Got it. This is awesome.
In
Thanks, Ron.
most cases. Yeah. All right, man. Talk to you guys later.